Hi my dear students, how are you? Hope you are doing great. Now we are going to discuss about current electricity in igcse. There are total 71 questions. We discuss few of them, the important and tricky questions. Okay. Okay, here the first question. The current in a car headlamp is 2 ampere. So here the current is given. I is equal to 2 ampere. The headlamp is switched on for 4 minutes. So time is 4 minutes. What we have to find, how much charge passed through the headlamp. So we have to find Q is equal to question mark. So here what is the formula? Q is equal to IT. Okay, the current is here 2 ampere. There is no unit change. So well and good, you can write. And then time, we need the unit conversion, 4 minutes. Change this into seconds. So multiply by 60. So you get your answer. You can multiply and check the answer. Use calculator. Second question, how can 1 volt also be expressed? So there is a formula, E is equal to VQ. So here energy, voltage, charge. So V is equal to energy over charge. So unit of energy is joules. This division is per, and unit of charge is coulomb, which means 1 volt is equal to 1 joule per coulomb. Right? Question number 3. Question number 3. The graph, voltage current graph for two resistor wires P and Q. There are two resistor wires P and Q. The wire are made from same material, have equal lengths. Both wires are equal in length, that is P and Q. But the area of cross section is not mentioned, right? And the question asks, which wire has the greater resistance? Which wire will have the greater resistance, P or Q? How do we know? Here you see, take any voltage and draw a line for the P and draw the vertical line, and the same voltage check for Q. Okay, this is this line for Q and this line for P. Which has more current? The wire Q has more current for the same voltage, right? Wire Q has more current, which means it has less resistance. So you have to find out like that. And another one trick, the line which is closer to the current, a line which is closer to the current will have less resistance, because the wire Q has more current, because this line is more closer to the current axis. The line P is more away from current axis. So more resistance, Q less resistance. So which has the greater resistance? This option A and B seems correct, and this option C and D is wrong. Larger cross-sectional area. Larger cross-sectional area increases, resistance decreases. So it will be Q, because the Q has more current, which means less resistance. So the option is here B. Question number 6. It is a parallel cells. What is the advantage? It lasts longer. What is the advantage? Last longer. So where is that? Longer time, right? A charge of seventh question, a charge of 7.5 coulomb, that means Q, flows through a resistor in 5 seconds. So time. So different ranges can cause measure the current in the resistor. Which ammeter range is most appropriate? So ammeter range, we have to find I. So what is the formula? Current I is equal to Q over T. So Q is 7.5 and time is 5.0 seconds, and then you can find out. 3 identical cells are connected in parallel resistors. So 3 identical cells, what is the advantage? It takes longer time to run down. Okay. Next question. When the flash on the camera is used, a charge of 1.5 coulomb flows through the flash tube. So here you write, whenever you read, just write the symbol, and here the time is here 0.0030. The average voltage across the flash tube is V. V is equal to 3600 volt. What is the electrical energy and what is the average power, they ask. We have the formula. E is equal to PT. Another formula is E is equal to VQ. So we can use any one of them. So I think we can use this formula, because since it is given, voltage and charge is given. What is the voltage? 3600. What is the charge? 1.5, right? So you get some answer X, right? So next we have to find the power. So power is equal to energy over time. What is the energy? The energy that you found, X divided by what is the time? 0.0030. Divide it, you can find the answer. Okay, next question. Question number 10. Here there is a length of wire. They say 1.0 meter length of wire, cross-sectional area 0.4 millimeter square, has the resistance of 2 ohm. Okay, note it down. 1 meter and 0.4 millimeter square, that is the length and area. What is the resistance? 2 ohms. Now the new wire has 0.5, which means 0.5 means the length is halved, so half of the length, and the same material length of wire, the same material, which is a cross sectional area 0.8. 0.8 is the cross sectional area, that means it is doubled. Length is halved and then area is doubled. So what is the new resistance, they ask. What is the formula? Resistance is equal to length over area. What is the answer for this? 2 ohm. This is the original one. In the question paper it is given 2 ohm for the old wire. The new wire, right here, R new is equal to, what is the length? Length is decreased for the new wire, and then area is increased by 2. Okay, so 0.5 divided by 2, length over area. That means 0.5 divided by 2 multiply by, what is length over area? The old wire has 2 ohms. So 2 to cancel. What is the answer? 0.5. So here the ohm is 0.5 ohms. Is that clear? Okay, next question number 11. The flash on a camera operates when the capacitor discharges through the flash tube in 3.2 millisecond. So the time is given 3.2 milliseconds. So should change this into SI unit. Milli, in the place of milli you write 10 to the power minus 3, that is T. Okay, what is the average current? The charge of 6 coulomb, they gave charge Q is equal to 6 coulomb, and you have to find the current. What is the formula? I is equal to Q over T. You can do it. Question number 12. Which physical quantity is produced by a calculation when the charge is multiplied by a potential difference is equal to E? What is the formula? E is equal to VQ. So if you multiply charge and potential difference, you get electrical energy. See, next question. There are 3 resistors, 10 ohm resistors are connected together to form X, Y, Z. This is the network X, Y, and Z. What is the order of resistance of the network going from smallest total resistance to largest? Smallest resistance, largest resistance. Here is the smallest and this is the largest. So if you connect all the resistors in parallel, will give you the smallest value. The same resistor, if it is connected in series, is the largest value. This will be the middle value. Okay, so X, Z, Y. Question number 14. What is the potential difference across 2 ohm resistor? What is the total voltage potential difference? 18. So this 18 will be divided by these two resistors together and this, because these two resistors are in parallel, right? So now here I give you one trick. The answer, the combined resistance for these two resistors is 4 ohm. How do we know? Here 8 and 8, it is applicable if the two resistors are in same in resistance. So what is the resistance value? 8 ohm. Two, are they having the same resistor? Yes. How many resistors are there? 2. So you divide the value by 2, you will get the result. This is the combined or the total resistance here. So now I redraw the diagram, same diagram. So here is 2.0 ohm. Here is how much? 4.0 ohms. So here is 18 volt. Now how many resistors? 2 resistors. What is the combination? Series combination. Now it is one after another, series combination. So in the series combination, the voltage, which mean 18 volt, will be divided by these two resistors, right? Now what we can do? First you add these two resistors. So 4 plus 2, 6. 6 ohms will take 18 volt. Now what is the question? 2 ohm resistor. 2 ohm resistor will take how much? Question mark. X. So multiply, cross multiply. 6 times x, 6x. 18 times 2, 36. So x is equal to 36 over 6. So 6 ohm, 6 volt. 6 volt is the answer. So do the calculation using your calculator and follow this method. For the MCQ, it is easy for you. They use cross multiplication method to find the voltage, because resistance and potential difference are directly proportional, so you can use cross multiplication. An immersion heater is labeled 24 volt, so potential difference V 24 volt and 120 watts, power rate is 120. What is the current? So we have to find the current, right? That's what is the current. What is the people are very important. Power, voltage, current. Power is equal to voltage into current. I is equal to P over V. Okay, you can substitute all the values and find the answer. Next question. A piece of wire has 16 ohm, another wire made from same metal, 4 times length and twice the cross sectional area. 4 times length and twice the cross sectional area. So if you cancel 2, that means 2 times length over area. What is the original resistance? 16. So you just multiply length over area. For the old one is 16. So the new wire will have 32 ohms. Like that you have to find. What is the current in the circuit? Here you see 12 volt and there are two resistors in series. They ask what is the current in the circuit. So here if you connect the ammeter, here you connect the ammeter, anywhere you connect the ammeter, any point in series you connect ammeter, you'll get the same, but you have to connect in series, not in parallel. If you connect ammeter in parallel, it is wrong connection. You have to connect voltmeter across the resistor if you want to find the potential difference. For the current, it is same in series, every point is same. So how do you find? There is a formula, Ohm's law. I is equal to V over R. What is the voltage? 12. What is the resistance? 2 plus 3, which means 5, because it is series in resistor, series connection. 3 plus 2, 5. So you can cancel 2 times 5, 10, then for 2.4 ampere. There is a current of 0.25 ampere. So I is equal to, connected to 240 voltage, so V is given. What is the power? What is the formula? Again the same, P is equal to VI. Use this. A lightning flash carries 40 coulomb, so Q is equal to 40 coulomb and lasts for 5 milliseconds. So time is given, so milliseconds, so I change this into seconds, 10 to the power minus 3 seconds. What is the average current? So we have to find I. So what is the formula? I is equal to Q over T. Then you will get the answer. Okay, students. Which of the following is equal to 1 volt? 1 volt is equal to joule per coulomb. We already did this. The electrical resistance of metal wire varies with the temperature. The temperature increases, resistance increases. At 0 degrees Celsius, the resistance is 1 ohm. And 100 degrees Celsius, the resistance is 1.40 ohm. You see, 0 degrees Celsius, it is 1.00 ohms. 100 degrees Celsius, it is 1.40 ohm. What is the difference? For every 100 degrees Celsius, here it is 0.4. The resistance is increased by 0.4. So the question is, what is the resistance of the wire at 200 degrees Celsius? So every 100 0.4, right? If it is 200 degrees Celsius, another 0.4 will be added. So 0.4 is 0.8 ohms. What is the initial resistance given? 1 ohm. So 1 plus 0.5, 0.8 is 1.80. So don't forget to add the initial resistance. Next, here is the current and voltage graph, and it is for the lamp non-ohmic conductor. If you see in the smaller current values, the resistance is constant for both lamp P and lamp Q. So the option is here, P has the same resistance as lamp Q at a lower current. At a lower current, both resistors are having the same resistance. Next question. Okay, in this battery and two bulbs are connected with ammeter. If this lamp L1 is broken, so how the current will pass through? It will pass through the voltmeter, right? So what happens here? The voltmeter, basically it has the higher resistance. So if the resistance is getting higher, the current value decreases, resistance increases, current decreases. So ammeter shows decreased value. So these two options are wrong. And what happened to the voltmeter? Since this resistance of the voltmeter is high, it will take more voltage. So the voltmeter reading increases. So the option is B. Which of the following is equivalent to 1 coulomb? 1 coulomb. So coulomb is the charge. What is the formula of coulomb? Q is equal to IT. So what is the unit of charge? Coulomb. What is the unit of current? Ampere. What is the unit of time? Seconds. So 1 coulomb is equal to 1 ampere second. 1 ampere second. Next. The diagram shows a circuit in which all the switches are open. Here there are switches, you see S1, S2, S3. All switches are open, and there are 3 resistors, 3 ohm, 3 ohm and 4.5 ohm. Which switch positions give a resistance of 6 ohm between X and Y? This is X and here is Y. Okay, first they ask you 6 ohm. Suppose if you close these two switch S1 and S2, what will happen? This become parallel. So now the two resistors are equal in size, 3 and 3. So what is the total resistance? 3 divided by 2. I told you before, if the resistors are same, you just can divide for our easy calculation. So the answer is 1.5 resistance. So here is how much? 1.5 ohms plus 4.5. How much? 6 ohms. So this together, it will become like this. Here is how much? 1.5 ohms, and here is the connection, the terminal X, and this 4.5 is here, 4.5 is here, and here is the terminal Y. So now it is in series in connection. I have changed this two resistor into 1.5, and this 4.5 resistor is here, right? The two terminal X and Y is here. So now what is the total resistance? 4.5 plus 1.5 will be 6.06 ohms. So you have to close this two switch and you have to open S3. So close, close, open. B is the answer. Okay, here they ask you to find the potential difference V. What is the formula of V is equal to IR? How do we know which formula that we have to use? You read the question and write the name of the given value here. Ammeter used to measure the current in a 300 ohm resistor. So the resistance is 300 ohm. The ammeter is shown below. 6 milliampere. 6 milliampere. Normally the students won't see this value, the unit. So actually we supposed to note what type of unit is given. So here is 6 milliampere. So current is 6 milliampere. What we have to find? Potential difference. V is equal to IR. What is current? 6 milliampere. So you write 6 times 10 to the power minus 3. What is the resistance? Here 300. So you multiply, you can find answer. So here is the which is the current voltage IV graph for the filament lamp. Filament lamp actually it is a non-ohmic conductor, non-ohmic. If it is non-ohmic, this option is wrong. There are two options, I, A and C, because here just gradually decreases, gradually increases. This one down, this part is not there. Okay, it will not go back. It will not go back. Current will not go back. So it is wrong option. This option also wrong. Now we have to select from this. So check where is the current axis. Here is the current axis. Here is the current axis. Here current increases. In filament lamp, as the voltage increases, temperature will increase. So resistance increases, current decreases. Voltage increases, current decreases. So voltage increases here, the value of current decreases. So the option A is correct. What happened to the lamp? The same concept. Temperature increases, resistance also increases. Same concept, repeated concept. Here they ask what is the ammeter value. Check voltmeter, voltage 12 volt, and here two resistors are connected in parallel. There is a formula R1 R2 over R1 plus R2. If the resistor, only two resistor, you can use this formula. So what is the resistance, total resistance? 6 times 3 over 6 plus 3. 18 over 9. 2 ohm is the total resistance. Now we have to find ammeter reading here. Now this ammeter is closer to the battery. The ammeter is not given here, right? If the ammeter is here, is actually the current is splitted. When it go to the branch, this is a junction. The point, the dot, the thicker dot, the dark point is a junction. In this junction, the total current will be divided like this. Okay? But here ammeter is here before the terminal, before this junction. Okay, if the ammeter is located before the junction, it will have the full value of current. So I is equal to total voltage over total resistance. What is the total voltage? 12. What is the total resistance? 2. So the current will be 6 ampere. Okay. So here they ask which switch is opened so that all the lamps are lit. Okay, first of all check. If you close this, the current goes here. So this is lit. Now close this. Now current goes here. This is the complete circuit. So this this lamp lights. And for the next lamp, here it is closed, but here it is open. So the both lamp will not lit, right? So what is important? The D. This also must be closed. So here also must be closed. So the current flows through the bulb 1, 2 and 3. Here it is correct, good to go. And here also the current flows through 2 and 3 and it is closed here, and it is a full complete circuit. It is a complete, the circuit is completed. So it is not necessary. Next question. A lamp connected 12 volt. So the voltage is 12 and the power is 36. And how much energy? E is equal to question mark. So what is the formula? E is equal to VQ. Okay. So here why the power is given? The time is here. So what we have to find? E is equal to VQ. Another formula, E is equal to PT. So the power is given 36. You can use this formula and the time is 10 seconds. So how much energy will be converted? 360 joules. So if you don't get if you cannot use any formula, just go for another formula so that you can solve your question. Okay, so energy has two formulas here, VQ and PT. There is one more formula, this PT, you see, expanded form. P is VI and the T. So there is another formula we can create, VIT. It is from PT. The basic formula is power and time. Power is VI, voltage and current, and time is here VIT. Okay. Same question, 32 repeated. And here we have to find the current, voltage, milliwatts. V is given, P is given, P over V. That is, this is the basic formula. Here current is equal to power divided by voltage. Don't forget to convert milliwatts, 10 to the power minus 3. Don't forget, 600 times 10 to the power minus 3. And substitute, get the answer. 3 identical cells are connected in parallel. 3 cells connected in parallel last longer. It takes longer time to run down. Okay, it's a repeated question. Combined resistance. What is the formula to find the combined resistance? 1 by R1 plus 1 by R2 plus 1 by R3 is equal to 1 by R. That is the combined resistance. Don't forget, if for example, if final answer is 2 over 3, R is equal to 3 over 2. Okay, you have to take the reciprocal. This is not for this question, just I give the common basic idea. Many students, they give answer 2 over 3, 2 divided by 3, they use calculator and then write the answer, select the answer here. So it will be wrong. Don't forget to take the reciprocal, students. Next question, 35. Here what is the formula? Length over area. That is the resistance formula. And here what is the total resistance? The same question. 666. Here you see 5, 5, 10. So you cannot use the trick. Previously I told you, here all the resistors are the same. So 6, write it. And how many number of resistor? 3. 6 divided by 3 is what? 2 ohms. So answer is 2. So use this method for MCQ. For theory you can show the calculation working. Okay. Here the next question. Here they give the resistance. Here they give the voltage. How much charge Q you have to find? For 30 seconds time is given. So Q is equal to IT. Okay, what is the current here? Current is not given. So what we have to do? We can use P is equal to VI. I is equal to P over V. What is power? Power, where is power? Power is not given. So you can use another formula, that is V is equal to IR. I is equal to V over R. What is V? Voltage is 5. And what is the resistance? Resistance is 10. So answer is 0.5 ampere. Now you can substitute. Current we found it using the Ohm's law, and the time is here 30. You multiply and find the answer. Next, Uh, Question number 39. It is tricky question. Which changes both cause a decrease in resistance. Decrease in resistance of a copper wire. Okay, here I read it. Decrease in length. Decrease in length decrease the resistance. So decrease resistance. And temperature of the wire lower the resistance, temperature decreases, resistance decreases. So length decrease, resistance also decreases, then and decrease the temperature, resistance also decrease. So decrease in resistance, this option is right. To check the other option, increase in length, resistance increases. So we need a decrease in resistance. Decrease in thickness, that means area decreases, resistance increases. So wrong. Increase in thickness, resistance decreases, but check the temperature, higher the temperature, so temperature increases, resistance increases. So we need a decreasing resistance, so the option D also wrong. It is because the temperature is higher. This side, left side is right, but the right side column, this column is wrong. Okay. Okay, next question number. This question number, the resistance of the wire is given, some numbers are given. I cannot see here. Okay, I will tell the concept here. The new wire has 4 times, the area of cross section is 4 times more and the length is twice the length. So what is the formula for this new wire? Resistance is equal to length is increased by 2, so 2 length divided by the area is increased by 4. So whatever the value is given, for example, if the value is here, for example, it is like 400 ohms. If it is 400 ohm, so how it will be 2 divided by 4 multiplied by 400. So you cancel it. So your answer will be 200 ohms. Okay. So just I give you an idea how to solve the question. Okay. Because I changed this format. So as I change the format from one to another, some numbers are not shown here. It is mixed up. Okay, students. Next question number 41. Here, what is the effect of connecting extra cells in this way? This is parallel connection. Cells are connected in parallel, so longer time. It will, the lamp produces light for a longer time. It lasts long. Repeated question. Okay, here it is important question. You see here, what is the reading on the voltmeter? This reading we need to find. Now you check what type of connection. It is series in connection. What is the maximum voltage? Here is 0, the other side 6. So the maximum voltage is 6 volt. I told you the resistors are directly proportional to the voltage. So you can cross multiply to find the answer. Easy to, without using the formula. So first you count add these two resistors. Since it is connected in series, total resistance 10,000 plus 2,000 is 12,000 volt. We'll take the total voltage. How much? 6 volt. Now we want to find the voltage reading across 10,000. So right here 10,000 volt. Sorry, here is ohms. 10,000 ohm will take X voltage, cross multiply. So 6 times 10,000 divided by 12,000. Use calculator, you can find the answer. Okay, students. Okay, question number 43. You can read it. What change will not reduce the value of the resistance of the wire? So the resistance affecting factors are 3: length, area, temperature. So the insulation cover will not affect the resistance. And they give you a set of reading, that is voltage and current, and they ask you to find which set of reading will give 100 ohm resistor. So what is the resistance formula? Voltage over current. So you need to just divide these two values. So voltage is 3, current is 30, not 30 milliampere. So 3 divided by 30 milliampere. If you use calculator, it gives you 100 ohms, because when minus 3 goes up, it will be 3000 divided by 30. Cancel this. So 100. So here 2 divided by 15 will not give you 100. But check here, 3, 30, 2, 20, 110, same values. 1 positive 10, 2 positive 20, 3 positive 30. But these all values are given in milliamperes. So the option B is right. If you divide these two values, you will get 100 ohms. What is the formula? Voltage divided by current. And don't forget to change milliampere to ampere. Next question. Here, charges on the electron, negative. Direction of electron flow, negative to positive. So the option is A. Here you see, this way electron flow of electron, the opposite side, positive to negative. This is negative to positive, right? Now positive to negative. This is called conventional current flow or current flow. Next, now when three identical resistors are connected in series, the combined resistance is 6 ohm. The combined resistance of this 6 ohms. So what is the value of each resistor? It should be 2 ohms, 2 ohms, 2 ohms. Say 2 plus 2 plus 2, how much? 6 ohm. It is given 3 identical resistors. So these same resistors are connected in parallel. So what is the total? Now you see all the resistors are in same value. Total, if you want to find the combined resistance, I told one easy, I told you a trick. Write the value of each resistor and number of resistors divided by 3. So what is the answer? 2 over 3 ohms. Next question. Okay, question number 47. The diagram shows an alarm system in which the switch S is shown closed. Where is switch S? Here. Here is switch S is closed. So what happens when the switch is closed? The circuit is completed. So current flows through the solenoid, and inside the solenoid there is iron core. So what happens? The solenoid is magnetized. It attracts the iron. There is an iron rod which is attracted by the solenoid. So what happens? Here is a gap. If here is a gap, the secondary circuit is incompleted, so the bell will not ring. When the bell will ring? If you open the switch, current flow is stopped. So what happened? The solenoid is demagnetized and it releases the iron. Iron falls. When iron falls, the secondary circuit is closed. So here is a battery, supplies current, so the bell rings. So what happened? When the switch S is opened, iron drops and bell rings. Question number 48 is also, they ask which pair shows the resistance and filament for the filament. Resistance for the filament. Okay, initially the resistance of the filament initially will have some resistance because the metal wire have resistance, and if you turn on the filament lamp, if the current flows through the filament, what happens? Temperature increases, resistance increases. So resistance increases, at the same time the current decreases. So option is B. Okay, so here resistance decreases, current also decreases. The concept is wrong. Resistance decreases, so in the filament lamp resistance will not decrease. So this option is wrong. Here resistance increases, correct, but the current also increases, wrong. Okay, next question. 1 volt is equal to joule per coulomb. Already we learned. Repeated question. What is the effective resistance of these three resistors? You know the formula. 1 over R1 plus 1 over R2 plus 1 over R3, and don't forget to take the reciprocal finally. Should take the reciprocal to find the final answer. Okay, Ohm's law states current in the conductor is proportional to the potential difference across it. Provided that a certain quantity remains constant. In the Ohm's law, which factor? There is a limitation. The limitation is temperature must be constant. In which arrangement current from the supply lowest and in which it is highest? So these resistors are connected in series, right? This is a heater. Heater means that each heater has a resistance. So it is connected in series. Highest resistance, lowest current. Highest resistance, lowest current. So the lowest current in X. These two options. These two are wrong. And then highest current. These three resistors are connected in parallel. See, here is the lowest resistance. So the highest current it has. The combination Y. So the option B is right. Okay, question number 53. Here it is shown, the circuit is shown. Here the question, which statement is correct? The current is flowing from the battery when near the battery. Here is the junction, and before junction, anywhere at this point from here to here, okay, the current is the highest. The value of current is high. And here in this, when the current flow, for example, if here is 3 ampere, example, I'm giving example for you, it splits, it is divided, the current is divided equally or unequally. If the resistors are unequal, current, the division will be unequal. So here the less resistance, more current will flow. So example, 2 ampere current will flow, and here 1 ampere. Is that clear? Because the current flow will be higher through the lower resistance. So through the lower resistance, but still where is the highest current? 3 ampere is the highest. So P is greater than Q. P is greater than Q. So that is the option, right? Q is equal to R. Here is Q and here is R. They are not equal because the resistors are unequal. So the option is wrong. R is greater than S. Here is R, here is S. In the same branch, in this branch, current is same every point. From here to here, the current flow is the same. So this option is wrong. S is equal to P. Here is S and here is P. It's not equal because the current is divided. So this option is also wrong. Okay, this is the same question. Ohm's law, filament question. And here the emitter has negligible resistance. What is the resistance of the resistor? Now we have to find the resistance here. Now here the voltmeter reading V is given, and here ammeter reading current is given. We have to find the resistance. What is the Ohm's law? V is equal to IR. R is equal to V over I. First we want to find the total resistance. So total voltage is 3. Total current is 0.5. So the answer is 6 ohms. So how many ohm is here? 1 ohm. So it is series. So how many ohm must be here to get 6 ohm? 5. So 5 plus 1 ohm is equal to 6 ohm. So your answer is 5. Under which condition Ohm's law apply? Temperature must be constant. So the same question, repeated question. And here Ohm's law can be applied from the point X and Y because the line is straight. It is proportional. Current and voltage is proportional. After that, it is not applicable. And here, what is the resistance of the second wire? Same, resistance is equal to length over area, the same concept. Okay, here some trick is here. Students, carefully listen carefully. What is the current in the meter? Now here I want to find the current in this point. So that means, so actually you have to construct like this. Okay, this is what the diagram is. Here is the total current. So here 4 ampere is there in the top branch, and the bottom branch current is not given. So how can you find this branch current? If you find the current through 12 ohm, and it is easy, the problem is solved. So first you find the voltage. How do you find the voltage? V is equal to IR. So the voltage here is, you multiply these two values, the current is 4, resistance is 6. What is the answer? 24 volt. And the battery should have 24 volt because these two resistors are in parallel, so the voltage is same for them. So here this resistor also will get 24 volt. So what is the current through this branch? Same Ohm's law, I is equal to V over R. The voltage for this resistor voltage is 24, and the resistance is here 12. So the answer is 2 ampere. Here is 4 ampere, and through this resistance 2 ampere. This 4 and 2 will join here. So 4 plus 2 ampere will be 6 ampere. Next question. Okay, 61, 62. Here in they ask here EMF. EMF means work done in a circuit for each unit of charge that passes. Work done in the circuit. Here, work done to drive charge throughout the circuit. EMF, the definition of EMF is very important. Work done to move charge. Here also the same, potential difference. Work done to move charge, to drive the charge between 2 points. So here the definition is actually the definition. Define, if you know the definition, you can solve this question. They ask this. So here, what is the potential difference across X and Y? Work done deriving unit charge between X and Y. Work done deriving unit charge between X and Y, because potential difference. Since the potential difference, EMF and voltage are the same, they have the small difference is there. Slight difference is potential difference between 2 points is the keyword, and this one throughout the point, or throughout the point. Between the 2 points is the keyword for potential difference. So what is potential difference? Work done to move charge throughout the circuit is EMF. Between the 2 points is potential difference. Okay, here which combination has the same resistance? Here 2, 2. Right, same resistance. If there are same, what is the combined resistance? I told you 2 divided by 2, the half of this, 1 ohm. And here you see on the top branch in series, at the bottom branch 2 resistors are in series. In series 1 plus 1, 2, at the bottom 1 plus 1, 2 ohms. So it look like P. So this combination, PS combination, is same. Okay, here is a voltage is given 12 volt. How much electrical energy? You have to find E. So here the charge Q is given. So what is the formula? V is given, Q is given. Formula is E is equal to VQ. And you have to check if it is the units are given in another system, the same SI system. Here also column SI system, so no problem, easily you can multiply. Okay, 65, if you read, you would know, same concept, resistance length over area. What is the quantity is called? It's a definition. You have to same energy Electrical quantity is defined as energy converted by a source driving unit charge around a complete circuit. I told around a complete circuit. Energy supplied to move a charge throughout, that means around a complete circuit, is electromotive force. Electromotive force. What is electromotive force? EMF. Okay.